Good day, good people, and welcome once more to Waffle TV. If this is your first time watching Waffle TV, this is a platform where we simplify, demystify, and exemplify elementary mathematics for your understanding. Last time, we treated cuboids and the different aspects like the volume, the length, width, and height of a cuboid. And we promised you that this time around, we're going to do something else as far as rectangular solids are concerned. So in today's lesson, we are going to be looking at the total surface area of a rectangular solid. We are also going to look at the total surface area of an open box as well as the area of four walls of a room. Stay put as we go deeper into looking at the different aspects of this shape. Before we start the lesson of today, we just want to call on you that you can join us in our initiative to support underprivileged learners in local communities with school materials. These young learners need our support in one way or the other. Visit our website at www.wapfu.com. WAPFU is WAPFOU.com. Visit this website as you see the different aspects in which we engage and identify how you can be of help or how we can work together for the good of our communities. Now, going back to the lesson of today, we have already looked at what a rectangular solid is. By the way, before the end or by the end of our lesson today, we should be able to calculate the total surface area of a rectangular solid. We should be able to calculate the total surface area of an open box or a closed box, and we should be able to calculate the area of four walls of a room. This said, let us go straight into solving some practical examples so that you can better understand how to apply the rule. Before we proceed, I just want to explain this rule on how to calculate the total surface area of a cuboid. If you look at this rule carefully, permit me write total surface area as TSA. And if you look at this rule carefully, you will realize that the first one is L times W times 2 plus L times H times 2 and W times H times 2. Why do we put this 2 here? As I earlier explained, L is the length, W is the width, H is the height, and these two simply stand for the two identical sides. Let's look at this example first of all, and it will better explain this rule. If we look at our first example, it says a metal water tank measures 10 by 8 by 7 meters. Find the total surface area. In this case, we are going to apply this rule. Now, let me explain this rule once again. L times W times 2 will be for the base, and the base here we can consider it to be the floor. The floor and the ceiling are the same. So when you find the length and the width of the floor, you multiply by 2 for the floor and the ceiling. Then the second part here is length times height times 2. This is the length and this is the height. So this will be for the face. This face has two sides. It has this side and the other side, and they are the same. So you multiply this face times 2. And the last part is the width and the height, which is for the smaller face here. This smaller face has the height and the width. So if you multiply the height and the width, you multiply by 2 for this side and this other side. Therefore, you understand that these two here stand for the identical faces of the cuboid. So now, let us substitute these figures into this formula and calculate as demanded. Total surface area, we've said, is length times width times 2 plus length times height times 2 plus height times width times 2. Now let's substitute. The length here is 10 times the width, which is 8 times 2 plus length is 10, height is 7, and you multiply this by 2 plus Height we've said is 7, and width is 8 times 2. Sorry, here multiply here by 2 and not by 8. So 10 times 8 is 80. 80 times 2 is 160, plus 10 times 7 is 70, and 70 times 2 is 140, plus 7 times 8 is 56, times 2 is 112. So if we add all this, it's going to give 412, and the unit is meters square. Remember, we are calculating for the total surface area, and so your unit should be squared. We only express the final unit in cube if we are talking about the volume. Let's move on to the next aspect, which is how to find the area, total surface area of an open box, which of course is in this shape, but open. Total surface area of an open box. Here is the rule. The rule says length times width plus length times height times 2 plus height times width times 2. This is our example for application. A swimming pool is 200 centimeters long, 120 centimeters wide, and 80 centimeters deep. Find the total surface area of its walls. So we're going to substitute these figures into the rule and multiply accordingly to find our total surface area. First, let's take the rule. Total surface area is equal to length times width only plus length times height times 2 in this case, plus height times width times 2 in this other case. Now let's substitute. The length of the pool is 200 centimeters times the width, which is 120 centimeters, plus length again 200 centimeters times the height, which is the depth of the pool is 80 centimeters, times 2, plus height, which is 80 centimeters, times width, which is 120 centimeters, times 2. Now let's find the answers in each of the parentheses. 200 times 120 is going to give us 24,000 centimeters, plus 200 times 80 times 2 is going to give us 32,000 centimeters, plus 80 times 120 times 2 will give us 19,200 centimeters. If you add all this together, this will give us a total of 75,200 centimeters square. And this is how you can find the total surface area of an open box. Now, in this case, the area of 4 walls. The 4 walls of a room has the following dimensions. The length is 6 meters, the width is 4 meters, and the height is 7 meters. What is the area of the 4 walls? Now, the rule here states that you find the perimeter of the floor times the height. And we know the perimeter of a rectangular floor is length plus width times 2. So let's apply this rule and substitute with the following figures to find the area of these 4 walls. First, we identify the length of the room. The length of the room is 6 meters. The width of the room is 4 meters. And the height of the room is 7 meters. Therefore, area of 4 walls will be equal to length plus width times 2. This is the perimeter of the floor. And we multiply our answer by the height. We can substitute here. Length is 6 plus width, which is 4, times 2 times the height, which is 7. 6 plus 4 is 10. 10 times 2 is 20. So here we have 20 times the height, which is 7. And this will give us a total of 140 meters square. This is what you are supposed to do as far as area of 4 walls is concerned. And if you followed up the lesson, this is what we had for you today. We believe you've learned something. If you did, give us a thumbs up and always share your thoughts in the comment section so that we can improve on the service. That notwithstanding, we believe you're going to join us in our initiative this year, 2023-2024 academic year, so that we can support the underprivileged learners in local communities. Click the link in the description and follow up the full project so that you can identify in which aspect you can be of help. You can also visit our website to see the different things we do apart from teaching elementary mathematics. The website is www.wapfou.com, and WAPFOU is WAPFOU.com. See you in our next lesson where we shall be talking about pyramids. Don't miss it. Goodbye.